Hey there! Today's problem comes in from geometry, and we are given a quadrilateral and about 1 billion facts about that, and we are asked to find the measure of an angle, another angle, and the measurement of a side length, or a segment. So this comes from a section called Congruent Triangles and CPCTC, which just stands for Corresponding Parts of Congruent Triangles are Congruent. It's really an ugly acronym, but it's super easy. It just means if you have congruent triangles, then each part of them is congruent. So let's get started. Okay, when I am given a picture and a ton of information, I just like to go point by point and say, all right, they gave me this, what does it tell me? Until I get to something important enough to write down. So H is the midpoint of GJ, so here's GJ, and H is the midpoint. Well, that tells me these two segments are congruent, so let's put tick marks in there. Then they say M is the midpoint of OK. Well, here's OK. M is the midpoint. Tells me the same thing about OM and MK. They are congruent. So put tick marks in there. Then they tell us GO is congruent to JK. GO right here, JK. Let's put tick marks in there. Would have been easier had they just said, hey, this thing is a parallelogram, but they didn't do that. So then they say angle G and angle K are congruent. So angle G is up here, angle K down there. Let's put little diamonds in because I'm running out of room. Then they tell us OK is equal to 27. So if OK has a length of 27, then GJ has that same length. But I already see enough information, and especially since I know this comes from the section of the book called CPCTC, I'm looking for corresponding parts of congruent triangles. So I first have to have congruent triangles. So I can see that I have side, angle in between, side. So this triangle right here is congruent to this triangle right here by side, angle, side. So let's get that down. GHO is congruent to KMJ by side, angle, side. Now, we need to know the measure of GOH. Well, GOH is in this triangle, and it has another part that it is corresponding to in a congruent triangle. And look, GOH has an algebraic expression here. It says GOH is x plus 24, and I bet I can find the corresponding angle. So GOH, well, yeah, that is going to correspond to this right here, KJM, or MJK, since that's how they named it. MJK, same as KJM. So this is going to correspond to this, and I have an algebraic expression for both of those. So I am going to go ahead and use that. And I'm going to say, listen, I know that GOH is congruent to MJK because they are corresponding parts of congruent triangles. And I know that I have an algebraic expression for each of those angles. And since this is equal to this, I'm going to set those expressions equal to each other. Geometry loves to do this. You've already been through Algebra 1. Let's use your knowledge of Algebra 1 and set these two expressions equal to one another. So we have variables on both sides. I don't want variables on both sides, so I'm going to gather them onto one side. Instead of subtracting 4x from both sides, I'm going to subtract x from both sides because that keeps my variable positive. So subtract x from both sides. 24 equals 3x minus 105. Now I still need to get x alone, so add 105 to both sides. I get 3x equals 129. Divide by 3, and I get x equals 43. Now, I am just going to pop 43 in for x in GOH because I don't really need the measure of MJK. They will be equal. I should get the same number, but I don't need it, so I'm only going to do it for GOH. All right, so GOH is equal to 43 plus 24, which is 67. So GOH is 67 degrees. And so is MJK, but they didn't ask us about that. So GOH, done, 67 degrees. Now they ask us for the measure of angle GHO. GHO is also in this triangle, and it is the only angle I haven't talked about having a corresponding part. So GHO corresponds to KMJ in this triangle. You can see it's next to the congruent angle inside, and this is next to the congruent angle inside, so they correspond. And I have algebraic expressions for both of those. GHO is 2y minus 7, JMK is 3y minus 23. So let's get all of this down. I know that GHO is congruent to JMK. GHO is congruent to JMK. I called it KMJ, but same thing. Because they are corresponding parts in congruent triangles, and so they are congruent. I also know I have an algebraic expression for each of those, so I am going to set those equal to one another and solve for y. I have y on both sides of my equation. I'm going to subtract 2y to keep everything positive. I get -7. Do not lose your negative. -7 equals y minus 23. Adding 23, I see that y is 16. Again, I only need the angle GHO, so I'm going to pop 16 in for y in that expression only, and I will see that the measure of angle GHO is 25 degrees. All right, what's the last thing I need? I need GH. All right, GH is half of GJ. And if you remember, GJ is 27 because OK was 27. They told us these two things were congruent. So then this thing is 27. So let's get this all down. I know that GJ and OK are congruent and that OK is equal to 27. Therefore, GJ is equal to 27. I also know H is the midpoint of GJ. So GH is half of that. So if I need the measure of GH, it is 1/2 of 27, which is 13.5. There you go. We found all three things that they wanted. It took a little bit of time, but it wasn't too difficult. Just remember, you need to find your corresponding parts of congruent triangles, and to do that, you need to find congruent triangles. I hope that helped. If you are having trouble with your geometry homework or your algebra homework or any homework for that matter, subscribe to our YouTube channel and send in those problems, and we'll make you a video as well. Until next time, have a good one.